What is IP address affinity technique for load balancing? IP address affinity, also known as a session persistence or sticky session, is a load balancing technique that ensures subsequent requests from the same client are always directed to the same server. This technique is particularly useful for applications that maintain state information about a client session, making it easier to manage stateful interactions. Let's talk about how the IP address affinity works. So, when clients makes a request to a load balanced service, the load balancer assign the client to a specific server based on the client's IP address. The load balancer then remembers this assignment and continues to route all subsequent requests from the same IP address to the same server. This ensures that the client has consistent session experience. Let's talk about the implementation or how it works, the implementation of the IP address. The first thing we have the initial request handling. When a client initiates a session, the load balancer selects a backed server based on the current load or predefined algorithm like round robin, least connection, etc. Second, we have session assignment. The load balancer records the client's IP address and the chosen server. Number three, we have subsequent requests. So for all subsequent requests from the client IP, the load balancer uses the recorded assignment to route the requests to the same server. And number four, we have the session timeout. So the load balancer may have a session timeout setting after which the affinity record is removed and a new server may be selected for new requests from the client IP. So let's talk about the use cases for IP address affinity. The first thing we have web applications, applications that maintain user sessions such as online shopping carts where user specific data must persist across multiple requests. Number two, we have stateful services, services that need to maintain state information for each client session such as chat applications or online games. Number three, we have legacy systems, so older systems that were not designed for distributed environments and rely heavily on session state stored locally on the server. So let's talk about the advantages of the IP address affinity. The first thing we would have, which is the consistency, ensures that users maintain a consistent session state across multiple requests, which is critical for stateful application. Number two, simplicity. So easier to implement than more complex state management solutions such as distributed caches or databases. And number three, compatibility. So works well with all applications that cannot be easily modified to support distributed state management. Let's talk about the disadvantages of the IP address affinity. The first thing we will find, which will be the uneven load distribution. So can lead to uneven load distribution if a large number of clients are assigned to a few servers, causing those servers to become overloaded while others remain underutilized. Number two, scalability issues. So, as a number of clients increases, the load balancer needs to maintain a larger number of affinity records, which can impact performance. And number three, failover complexity. So, if a server fails, maintaining a session can be can be quite complex as the load balancer needs to reassign clients to a new servers and manage the state transition. So, in conclusion, IP address affinity is useful technique for maintaining session consistency in stateful applications. While it is simple to implement and to use with many legacy systems, it comes with challenges related to load distribution and scalability. By carefully considering the use cases and potential drawbacks, you can decide whether IP address affinity is the right solution for your load balancing needs or not. So that's it for this video, and see you in the future.